All right, let's crack a code that's hiding in plain sight, inside every single digital picture you've ever taken. The question sounds simple, but the answer, well, it's pretty fascinating. What does a computer really see when it looks at a photograph?
You know, when we look at a photo, we see so much more than just an image, right? We see a story, we feel the warmth of a smile, the incredible colors of a sunset, that perfect memory of a great day. It's art, it's emotion, it's a human connection, basically frozen in time.
But what about the machine that's showing it to you? Your phone, your laptop? When it looks at that exact same photo, it sees none of that. So, what is it seeing? That is what we are going to demystify right now.
And this table just lays it out perfectly. It's a tale of two completely different visions. Where we see art, a computer sees math. Where we see a familiar face, it sees a grid of integers. For a computer, every single photograph isn't one story. It's this massive matrix of cold, hard data. So let's pull back the curtain and see the raw numbers behind the illusion.
To really get our heads around this, let's start with the absolute simplest kind of image, a black and white or grayscale photo. This is where the whole idea of painting by numbers really kicks in.
So here's the most crucial part. Every single dot in that image, we call it a pixel, is just a number. That's it. It's on a scale from 0, which the computer understands as pure black, all the way up to 255, which is pure white. And every shade of gray you can imagine in between, well, that's just a number from 1 to 254. It is literally that simple.
Okay, now look at this. This grid of numbers is basically an instruction manual. Imagine you're giving the computer a to-do list for drawing on a little 8x8 grid. You're not saying, draw an eye right here. No way! You're saying, make this square white, which is 255, and make this square next to it black, which is 0. This is the only language it gets.
And when the computer follows those 64 numerical instructions to the letter, this is what you get, a simple smiley face. This is that aha moment. That drawing you're looking at isn't really a drawing to the machine. It's just a visual representation of that spreadsheet of numbers we were just looking at.
All right, so that's black and white. Pretty straightforward. But what about color? This just adds another layer, or, as a computer would see it, another dimension of numbers. Let's see how that works.
And this right here is the key. While a grayscale pixel was just one lonely number, a color pixel is a team effort. It's a combination of 3 numbers. Think of it like a recipe with 3 core ingredients for every single dot on your screen.
And what are those 3 ingredients? Red, green, and blue. You've probably heard of it, RGB. For every single pixel, the computer is asking 3 questions. How much red should I use on that same 0 to 255 scale? How much green? And how much blue? Then it just mixes them all together to get the final color.
Let's look at this tiny 2x2 image. The pixel in the top left is just a list of 3 numbers, 255, 0, 0. That means all the red, none of the green, none of the blue, which of course gives us pure red. Now look at the bottom right, 128, 0, 128. That's a little bit of red, no green, and a little bit of blue, and that mixture creates purple. Literally every color you've ever seen on a screen is just a unique 3-number combo like this.
So, let's take this idea and apply it to something we all have, a photo from our phone. The scale of the data we're talking about is about to get absolutely mind-boggling. A completely standard high-def photo is a grid that's 1920 pixels across and 1080 pixels down. If you do the math, that's just over 2 million total pixels. 2 million tiny dots all working together to make up that single picture.
But hang on, remember, each of those 2 million pixels isn't just one number. It's 3 numbers for red, green, and blue. So we have to take our 2 million pixels and multiply that by 3.
And that gets us to this, just a staggering number. Over 6 million. 6,220,800 different numbers, all needed just to describe one single photo to a computer.
So let that really sink in. That selfie you just took, that beautiful landscape photo from your vacation, to your computer, it's not a picture. It's a list, a very, very long list of over 6 million numbers that it has to read in order, just to create that image on your screen.
Okay, so why are we doing this? Why go through all the trouble to demystify a photo? Why does it even matter that an image is just a list of numbers? Well, the answer has everything to do with the future of technology, artificial intelligence.
Here's why this is so critical.
You can't just show an AI a picture of a cat and ask, what is this? An AI doesn't have eyes. But what you can do is feed it that list of 6 million numbers. See, AI models are built on math. They learn by finding patterns in numbers. By turning images into these huge lists, we're giving them the raw data they need to learn to identify objects, faces, and even whole scenes. This translation from picture to numbers is the very first step in teaching a machine how to see.
And that leaves us with a final, kind of provocative thought. We've just seen how something as complex, as artistic, and as emotional as a photograph can be completely broken down into a simple, logical list of numbers. It really makes you wonder, what else in our world can be translated into the language of data? And what are we going to be able to do once it is? Thanks for tuning in.